Hello there, hello all. Welcome to Learn with Mr. Tamuli. If you are keen to learn, you have found the right tutor. That's me, Mr. Tamuli. Let me introduce to you someone who is intelligent and very smart. Here comes Subhodip. Subhodip will present this tutorial on my behalf. I am sure, you will find Subhodip's presentation very absorbing.
Hello friends. My name is Subhodip. Actually, I am a virtual assistant of Mr. Tamuli. Today I shall be presenting this tutorial on behalf of Mr. Tamuli. In this series of tutorials, we are learning mathematics of class 6. We are in the first chapter, namely knowing our numbers. This tutorial is tutorial number 3.a for chapter 1. In the previous tutorials, we learned the concept of place values and the concept of zero in the decimal number system. We also learned about the evolution of numbers in human history. In this tutorial we shall discuss the history of the decimal number system. Learning this history will help you get a better understanding of numbers. At the same time, you will realize that numbers are actually more fun than you think. This is Sukanya. She doesn't like numbers and arithmetic. I am sure Sukanya will start liking numbers once she gets to know the history of numbers. During the course of this tutorial I shall explain to you, why do we need to learn numbers, arithmetic and mathematics as a whole. Our aim is to instill a sense of purpose in boys and girls like Sukanya in their learning of mathematics. Towards the end of the tutorial, we shall also get ourselves introduced to Roman numerals. So, without further ado, let's begin this tutorial. As we all know, one of the most important features in the study of history is timeline or years and dates. For instance, when I say, Ashoka the Great ruled the Indian subcontinent from 268 BCE to 232 BCE, I am referring to a certain period in the timeline. To understand the terms like BCE and CE, let's first quickly learn about the Gregorian calendar. We need to know this for our discussion of the history of the decimal number system. The English calendar that we use routinely is known as the Gregorian calendar. It is called the Gregorian calendar because this calendar was promulgated by Pope Gregory XIII. He was the Pope from the year 1572 to 1585. Now, to understand the Gregorian calendar, let's look at a timeline chart. As I explain the timeline chart, please observe the mouse pointer carefully on your screen so that you can follow me properly. As per the Gregorian calendar, we start counting the years from the day of incarnation of Jesus Christ. Incarnation of Jesus, in fact, divides the timeline into two different eras. The years post the birth of Jesus are referred to as AD. The full form of AD is Anno Domini, meaning in the year of the Lord. Nowadays we use the term CE in place of AD. CE means common era. So, the year that succeeded right after the incarnation of Jesus is termed or written as 1 CE. Similarly, the 500th year after the incarnation of Jesus is written as 500 CE. Currently we are living in the common era year 2022. That means, a total of 2021 years have gone by since the birth of Jesus Christ. Now, let's come to the other era, that is, the era that preceded the incarnation of Jesus. The pre-Jesus era is called the before common era, in short BCE. Originally, in the Gregorian calendar, the term before Christ or BC was used for the years preceding the birth of Jesus. But now, use of the term BCE is preferred to that of BC. So, the first year that preceded right before the incarnation of Jesus is 1 BCE. The second year is 2 BCE and so on. And moving further backwards in the timeline we reach 232 BCE, which is the year when the reign of Ashoka the Great ended. Moving even further back we reach 268 BCE, the year when Ashoka's rule in India started. That means Ashoka the Great ruled India for about 36 years. The point to be noted here is that the years in the pre-Jesus era are counted backwards. Now we can get the Gregorian calendar out of the way and move to the history of the decimal number system. I have told you in one of the earlier tutorials that the decimal number system is also called the Hindu-Arabic system. Because development and use of this system first took place in India. I also told you that it took our ancestors quite a few centuries to perfect the decimal number system, and it was a collective human effort. Therefore, it is quite obvious that a single person, or a certain group of people can't be named or credited as the creators of the decimal number system. If you are asked who invented the incandescent lamp, or the electric lamp, the name that comes to our mind is Thomas Alva Edison. Even though there must have been a group of people who assisted Edison in creating his electric lamp, it was Edison who first conceived the idea and design for the electric lamp, and patented it. So, Thomas Alva Edison deserves the highest credit for creating the electric lamp, and rightfully, we know him as the inventor of the electric lamp. Here, let me also tell you that the electric lamp is a technology. And each and every technology is backed by science. Edison's technology of the incandescent lamp was made possible by advancement in electrical science. Knowledge of the decimal number system is actually one of the most vital roots or bases that enabled progress of modern science. Even though the decimal number system originated in India or in the Eastern world, development and progress of modern science and technology actually happened in the Western world. That is, in Europe and the United States of America. Let us have a look at Google Earth in order to consolidate our understanding of the locations of Europe and the USA. Our initial location in Google Earth is over the United States of America. We shall first zoom out a little bit. Then we shall move a little downward or towards the south. And then, we shall move in the westward direction or towards the left-hand side across the Pacific Ocean to reach Asia. Let us now zoom in a little on India. The decimal number system was conceived here in India, and the early development of the arithmetic algorithms and algebra associated with the decimal number system took place in India. This knowledge from our part of the world got introduced to the Islamic world of Arabia first in the 9th century CE. The Islamic civilization of Arabia contributed greatly in advancement of the knowledge of algebra associated with the decimal number system. This knowledge that was being nurtured in India and Arabia reached Europe in the 12th century CE. In order to find Europe in Google Earth, we shall again zoom out a little. Then we shall move a little northward and then in the westward direction to locate Europe. In Europe, the decimal number system attained its final and modern form by 15th century CE. Gain in knowledge of the decimal number system had a catalyzing effect on the progress of science in the Western world. Faster progress of science, in turn, fueled invention of technologies. Starting in the mid-18th century until 1900 CE, Europe and the United States of America saw invention after invention in quick succession. This period is famously known in history as the Industrial Revolution. I would like to take this opportunity to share very briefly with you some information about a few inventions that revolutionized our world and drove us towards technological progress. Before I do that, let us move back to our initial location in Google Earth, which was the United States of America. To reach the USA from Europe, first we shall zoom out a little. Then we shall move downward and then westward to cross the Atlantic Ocean. Finally, we shall move a little upward to locate the USA and zoom in on there. Let us now take a look at some of the most prominent inventions of the Industrial Revolution that took place in Europe and the USA in the period from 1750 to 1900. These 150 years forever changed the lives of the people in Europe and the United States of America. This image of a painting that I have taken from Britannica.com depicts the Industrial Revolution in Europe. One of the early inventions of the Industrial Revolution was the invention of the steam engine. James Watt, who was a Scottish national, designed and created an improved steam engine in the year 1765. This steam engine was used for pumping out water from mines, for example an iron ore mine. James Watt designed another version of his steam engine in the year 1780. This new steam engine soon found application as the primary source of mechanical power for running industrial machineries. This image dates back to 1876 from Philadelphia, USA. In this image you can see a gigantic steam engine named Collis, which used to generate enormous mechanical power to be used for running a whole lot of different machineries. In 1803, British engineer Richard Trevithick created the first steam engine that could be used as a railway locomotive. But the steam engine that was used in the first commercial railway carriage was designed by another English engineer, George Stephenson. Stephenson's railway locomotive made its maiden run between Liverpool and Manchester in the year 1825. In this image you can see one of the earliest railway steam locomotives. American engineer Robert Fulton designed the first commercially successful paddle steamer, or the steamboat. Fulton's steamboat traveled up the Hudson River from New York City to Albany for the first time in the year 1807. The distance between New York and Albany is about 240 kilometers. This image of a painting shows Fulton's steamboat, more famously known as the Clermont, traveling proudly in the Hudson River. A whole lot of life-changing inventions took place within the span of about 150 years during the Industrial Revolution. Here we shall talk about two more important inventions. One of them is the incandescent lamp, or the electric lamp, which we learned about briefly a little while ago. Thomas Alva Edison in the year 1879 invented the electric lamp in the United States of America. Joseph Wilson Swan, who was an Englishman, also created the electric lamp parallelly and independently in England in the year 1878. But Thomas Alva Edison is given almost all the credit for this invention because his work with the electric lamp was far more extensive as compared to that of Swan. The other invention that I would like to talk about here is the invention of the telephone. Scottish-born American scientist Alexander Graham Bell invented the telephone in 1876. The first call that Graham Bell made with his device was to his assistant Thomas Watson. The conversation happened between two rooms at Alexander Graham Bell's laboratory in Boston, USA on March 10, 1876. Alexander Graham Bell summoned his assistant with the famous words, "Mr. Watson, come here. I want to see you." I have given a link in the description of this tutorial video to an audio link where Thomas Watson himself is speaking about Alexander Graham Bell and the invention of the telephone. You can listen to that piece of historical audio clip. In this image, Alexander Graham Bell is seen inaugurating the long-distance telephone link between New York City and Chicago on October 18, 1892. The distance between the two cities is about 1520 km. Graham Bell's great rival Elisha Gray also independently designed a similar device for transmission of human voice. However, the patent for the telephone was awarded to Alexander Graham Bell on March 7, 1879. If you study history, you will find that in most of the inventions there are more than one contenders vying for the credits of an invention. But for winning the credits, here are some of the most essential criteria. First of all, your technology must be absolutely unique. You should apply for the patents earlier than anyone else. The design and the detailing of the device or technology should be done most extensively, and so on. As I have told you, development and progress of modern science and technology took place in Europe and the United States of America. I shared with you some information about the invention of the steam engine. We all know that nowadays we don't use steam engines anymore. Today we have petrol engines and diesel engines that run our vehicles. We also have electric railway locomotives. Nowadays we have highly advanced cryogenic rocket engines to fly into space. The point I am trying to make here is that technology is not static. We keep on improving the technology in order to meet the needs of new and more difficult challenges, and also to make the technology more and more efficient. Likewise, in the case of electric lamps, nowadays we mostly use LED bulbs. There are CFL bulbs also. But the LED bulb is the latest and the most advanced technology in the field of electric lamps. The incandescent lamp technology invented by Thomas Alva Edison uses a filament. You must have noticed this filament in a conventional electric bulb. A 12-watt LED bulb will give you the same illumination as a 100-watt conventional electric bulb. So, LED bulbs are far more efficient and consume much less power. Here I would like to tell you that watt is the unit of power. As a mark of honor to James Watt, the unit of power has been named as watt. As you already know, James Watt invented the first steam engine. I would like to tell you that steam is laden with energy, and the steam engine converts the energy of steam into mechanical power. The telephone invented by Alexander Graham Bell transmitted human voice through cables. The cellular phone technology of today is a wireless technology capable of transmitting not just voice but text, images and videos as well. With a smartphone you can make video calls from anywhere to almost everywhere in the world. So, the point is that all technologies are being improved and upgraded constantly. Improvement in technology is made possible by scientific research and progress of scientific knowledge. And for doing scientific calculations and computations, you need numbers and number systems. This is one of the most important uses of numbers. So if you have an ambition of creating a more advanced electric bulb than an LED bulb, you must learn numbers and number systems meticulously. This will give you the foundation to progressively learn more complex mathematical computation to solve scientific problems. As you know, we use numbers routinely for day-to-day uses like counting, measuring, timekeeping, etc. I had once met a 5th standard student named Rahul. Rahul disliked and feared mathematics. He had this strange idea that numbers and arithmetic operations like addition, subtraction, multiplication, division, etc. are puzzles, and these were created intentionally by some people for the purpose of examining the mental abilities of school children. Rahul thought that mathematics makes his life miserable. If you have a similar opinion as that of Rahul, I would like to correct you and let you know that in reality numbers and number systems were created by intelligent people in order to solve real-life problems. So, please remember that numbers and mathematics as a whole has got real-life applications. If you go to the grocery shop in your neighborhood to buy, say 150 grams of almond badam, and the shopkeeper tells you that almond badam costs rupees 900 per kilogram, you need to know arithmetic calculations to find out the cost of 150 grams of almond. This is one of the most basic real-life applications of numbers and mathematics. And at the highest level, the application of mathematics is to solve scientific computations to create new technologies. I would like to repeat here that the transfer of knowledge of the decimal number system from Asia to Europe played a big role in the faster progress and development of science in Europe. In the next tutorial, that is in the tutorial number 3.b, we shall talk about the invention of a relatively new technology, which is the technology of computers. After knowing about this invention, I will tell you about the significance of number systems in computer technology. We shall then continue our discussion about the history of the decimal number system. So, let's meet again in the next tutorial.